Today is the last section of chapter 1. Woo! And we're going to have some more fun doing some logic. So in section 1.7, we talked about the conditional statement again. That is when it's in that if, then, hypothesis, and conclusion. And you learned about the converse. And we learned that the converse isn't necessarily true. That we have to, investigate and determine if it's true or not. So let's start here. As I said, a reminder is a conditional statement is in the form if P then Q. And so this would be also, we write it as P implies Q, where P is our hypothesis and Q is the conclusion. So we're going to get some practice writing some conditional statements. So a declarative statement is just a fact. Matter of fact, two straight angles are congruent. The question is, how can we turn this into a conditional statement? So, it's almost like a definition or something, declarative. So we could say, if two angles are straight angles, then they are congruent. So that's how we would change that to conditional. So in other words, we have two straight angles. That's going to be our hypothesis. And then our conclusion, I should probably do P and Q. So that's our P, and then this is our Q, right? So if two angles are straight angles, then they are congruent. I sometimes think this is the most challenging part, taking a statement and making a conditional statement. So let's try another example. And that is 16-year-olds are allowed to get a driver's license. So let's write that as a conditional statement. You try it at home and then pause it, and then we'll go over it together now. So if a person is 16 years old, then they are allowed to get a driver's license. As you all know, that's not the only criteria, right? There's a lot of driver's ed and drive time and logging hours and all that other stuff. But 16-year-old is a criteria. So there we go. Now, negation, I'm going to put that in red, negation. The negation of any statement is the statement not P. So to negate something means it's not this, right? So in the example above, if a person is not 16 years old, that would make them not 16 years old. The symbol is that squiggly line, which is so much fun to make, right? So we would say not P. That's how we would write it. So not something, not P or not Q. We put that little squiggle in front of it. Okay, so we learned about the converse the other day. So if we have a conditional statement, it is P implies Q, or if P then Q. And we learned the converse the other day was if Q then P. We flip-flop it. Now we're going to learn the last two types of statements. First of all, the inverse. The inverse is negating the conditional. So not P implies not Q. If not P, then not Q. And then the contrapositive is if, not Q, then not P. So notice that the conditional and then the inverse is just negating the conditional. And then we have the converse, which is the flip-flop. And then the contrapositive is negating the converse or negating the flip-flop. So let's practice writing these. We need to know this. If I was taking a quiz or a test, I would probably, write that. Or wait, let me back up. I would probably write this on the top of my paper and just do conditional. Oh, that doesn't work. Conditional, converse, inverse, contrapositive, contra. Just to give myself a little key there, right? Let's practice. So, our conditional is if you live in Detroit, okay, that's our P, then you live in Michigan, Q. If you live in Detroit, then you live in Michigan. So the converse, and we're going to do a lot of writing in math class again. The converse is if you live in Michigan, then you live in Detroit. Okay. And again, that is our Q implies P. What do you think about that statement? True or false? False, right? I live in Michigan and I don't live in Detroit, right? So, yeah, there's a lot of other cities here in Michigan. The inverse, remember, is not P implies not Q. So the inverse is going to be if you don't live in Detroit, then you don't, or do not, right, live in Michigan. All right, what do you think about that one? True or false? Right? I don't live in Detroit, but I do live in Michigan. So there you go. And then finally, the contrapositive. Remember, the contrapositive is not Q implies not P. So if you don't live in Michigan, then you don't live in, oops, that looks weird, in Detroit. What do you think about that one? Ding, 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 ding. True, right? If you don't live in Michigan, you can't live in Detroit. True. So let's take a look at what we have here. So our first one, our conditional, was also true, wasn't it? If you live in Detroit, then you live in Michigan. That's true. So what I want you to note here is that the conditional and contrapositive have the same truth value. Okay, so they go together. These two go, oops, I passed it. These two go together. Okay, and then similarly, these two go together. So the conditional and the contrapositive have the same, oops, that looks weird, truth value. And then the converse and the inverse have the same truth value. Okay, so the conditional and the converse go together. The conditional and the contrapositive go together, and then the converse and inverse go together. So that leads us to our theorem. If a conditional statement, oops, that should say is true, then the contrapositive of the statement is also true. So if P, then Q, then if not Q, then not P, okay, and vice versa. Okay, so if the contrapositive is true, then the conditional is true. So they go together. Now, we started getting a little bit into this with the last section, but chains of reasoning. So we talked about the other day, you can only go with the river, right? That only if you have P can you conclude Q. If you start with Q, you can't make P a conclusion. The river only goes one way. However, there are also, as we just talked about, if you have P implies Q, then we also have not Q implies P. Oops, I'm sorry, not P. Then the contrapositive is also true. So, you know, that's also a possibility. So the river goes, you know, if you have P, you can conclude Q. However, if you have not Q, you can conclude not P. Similarly, with Q implies R, right? If Q implies R, then we know not R implies not Q. And then if P implies R, then not R implies not P. Okay. Yeah, I was getting ahead of myself here, but I'm just going to take this out. So what they're saying here with this chain of command is if P implies Q and Q implies R, then P implies R. In other words, you can make this chain look like this, right? If you can make the arrows all go in one direction and they all are flowing the right way, then, you know, you can make that conclusion then that P implies R, because you've gotten there. You've gotten through a logical chain of reasoning that's all flowing in the right direction. So let's look at this example here. So it says, if you study hard, then you will earn a good grade. So let's put this in terms of symbols. I think that helps a lot. So let's start with you study hard. We're going to call that P. And then you earn a good grade. That's our Q. Okay. And so we have here, I'm going to write P implies Q. Okay. And then I'm going to run out of room there. That's not where it belongs because I have another example there. So I have P implies Q. Okay. And then it goes on to say, you earn a good grade. Remember, that was our Q. And if you earn a good grade, then your family will be happy. We'll call that R. So this says Q implies R. So we could put this all together. If you study hard, you will earn a good grade. And if you earn a good grade, then your family will be happy. And so we can come up with that final P implies R. We can make a conclusion that if you study hard, then your family will be happy. All right? And we reason our way through that chain of reasoning. All right, let's look at this example here. So this is for you to practice now. This is for you to practice. So we're going to just practice converse, inverse, contrapositive. So two angles are straight angles. That is our P. Then they are congruent, Q. So what you're going to do, you can pause and then play it. But I want you to write the converse, inverse, and contrapositive. All right, pause it, come back. Converse. If, and remember these have to make sense, if two angles are congruent, then they are straight angles. Inverse. if two angles are not straight angles, then they are not congruent. There we go. And finally, the contrapositive, we have if two angles are not congruent, then they are not straight angles. Okay, so truth values. Truth values. If two angles are straight angles, they are congruent. True. If two angles are congruent, then they are straight angles. Not necessarily, right? You could have two 90-degree angles, and they're congruent, but they're not straight. If two angles are not straight angles, then they are not congruent. Again, you could have two angles that are not straight angles, like right angles, and they still could be congruent. But if two angles are not congruent, then they can't both be straight angles, and that is true. So again, notice that the conditional and the contrapositive have the same truth value. The converse and inverse have the same truth value. Now, here's our last fun example. And so what you want to do these problems, I'm going to give you some instructions first. So write statements in shorthand. We're going to write down the instructions and then we're going to do it, so then you'll get it. Write contrapositives in shorthand. And then finally, identify a hypothesis that is not repeating, and follow chain of reasoning. All right, so let's follow these instructions. All right, so we're going to make up shorthand to do this. So if gremlins grow grapes, then elves eat earthworms. So if gremlins grow grapes, then elves eat earthworms. Okay, so that's what we have. Gremlins grow grapes, that's our G. Elves eat earthworms, E. If trolls don't tell tales, okay, so notice it's do not. So not T, okay, if trolls don't tell tales, then wizards weave willows, okay? So if it has a not or don't or something like that, then it's a negation, and we have to do a negation of that. The last one is, if trolls tell tales, so that would be T, then elves don't eat earthworms, so that would be not E. So our contrapositives would be, and I'll put them over here, it would be not E implies not G, not W implies T, remember negating, right? Not T is T, and then this is E implies not T. So on here, when we look, notice that we have just on our left column, we have two E's, we have two T's, and then we have a G and a W, right? So the G and the W do not repeat. So we want to start with either G or W because they don't have a repeating. So let's start with G. Let's start with G and see what happens. So If gremlins grow grapes, this is like if you give a mouse a cookie, right? If you give a mouse a cookie, then what happens, right? If gremlins grow grapes, then elves eat earthworms, okay? Now, we look here, it's kind of like this, right? If elves eat earthworms, then trolls don't tell tales, then not T. If trolls don't tell tales, whoop, there we are, then wizards weave willows. And I think we're done, right? Because I don't see another W here. We're not going to necessarily use everything, but it's when we reach a dead end using all of our tools, then we're done. So what this means is basically our conclusion is if gremlins grow grapes, then wizards weave willows. Now, you might have said, well, what if I started with not W? Oops. Because we have to start with something on the left, too, I should have said, right? We have to start with something that is on the left of any conditional statement. So what if instead we started with that? Well, it would have been T, and then T goes to not E, and then not E goes to not G. So we would have ended up with not W implies not G, where up here we had G implies W as our final. And notice it's the contrapositive, right? So they're both correct. They're both correct.